Okay, guys, so here we are today. Xantha and I are basically here to demonstrate the 4 other factors that influence reaction rates. So what Xantha is doing is essentially she's massing out the candle before we start burning it. So what you guys are going to notice in terms of numbers, it's around 24.788 or 89, okay? And what's going to happen is I want you guys to, oh, she's lighting up the match here.
I'm trying to blow it out.
Yes.
Okay.
Yeah, so what she's gonna do is at the same time as she's gonna light it, she's gonna turn on the stopwatch. And basically every 30 seconds, was it, Zeta?
Yes.
We take the mass. And as you guys can see right here, the mass is slowly dropping as the candle is burning. And that's because that paraffin, which is a huge molecular formula, C25H52, is being broken down into carbon dioxide and water. Okay? So every 30 seconds or so, we're going to take the mass.
For a total of, I think, 300 seconds.
Yeah, we go for, I think, 3 minutes, right? Yeah, so that's the idea behind what's happening here. So we're just going to tell you at 60 seconds approximately what mass it is, okay, just so that you guys can have kind of a reference. And you notice it's fairly slow. You have like 0.01 of a gram drop about every single second or so. Okay, and we're going to compare this to another fuel that we like to burn so much.
That's 1 minute, 24/710.
24/710. So approximately that. Okay, so now we're just gonna blow the candle out because we're not gonna make you guys sit through the whole 3 minutes. That would be torturesome. Absolutely torture.
Now this is a different fuel. Okay?
Yeah. This is what fuels are we using right now, Xantha?
This is ethanol. So C25.
C2H5OH.
Yes.
So
the other one was.
So Xantha's writing out the formula for the paraffin, which we burned first, and now she's going to write out the amount that she's burning for the ethanol.
Okay, and the states are important. This
Yep.
is important.
Yep.
And the size of the molecule.
Right. Okay. So this has to do with the nature of the reactants. Okay, guys. So basically, what type of fuel we're trying to burn, and you notice there's a lot of commonality between them because basically they are all made up of carbon and hydrogen. Now, what you're going to notice, and I'm just going to, once Xantha's lit the splinter, I'm going to just check the mass for you guys, okay? You're going to notice it's approximately 138.65, let's say, 644. So once she lights it, we're going to time it for a minute and see how much it drops by, okay? So let's get going. And, ooh, tough to light, but holy cow. Okay, excuse me.
Now you can see it's going down more fast.
Now look at that, guys. Remember every second before we had like basically 1,000th of it dropping, right? Now it's dropping probably by 100th every single second. Okay, so it's just about 10 times faster in comparison to the paraffin. And if you look at the molecular formula, that pretty much holds true to the number of bonds. Okay, in terms of if you're trying to compare the ratio of the two. Okay, so we're just gonna keep on this for until a minute has passed, and you guys notice right here, right now, only just about 30 seconds has passed, and we use up way more fuel in comparison to what we used before. Okay, so that's the idea behind the nature. Remember, we talked about this. Okay, when you compare solid to liquid, a liquid is the one that has more energy, which means that it will react faster. And in this case, since paraffin has more bonds, it has to be broken. Paraffin will take longer as well. Okay? So we are done at a minute, and you can notice
137.960.
almost a whole gram gone. Okay, it's a lot. Okay, especially that it only happened inside a minute. Okay, so thank you, Xantha, for that part. We are now going to move on to our second demonstration, which has to do with, I believe, concentration.
Yes, it does. So this one, I'm going to need you to tell me the amounts and which one I'm doing first.
Okay.
Okay.
Yep.
So if you can pull that up and bring it around here so I can see.
Yep.
It.
So guys, let me, I want to put you on hold for now. Just let me go ahead.
So we're gonna put 20 mils into this one, and we're gonna time it to make a precipitate.
So guys, what's important to remember here is that in these flasks that I'm filming for you guys right in front of me, that is the HCl, okay, that 1 mole of HCl. And what Xantha is doing is essentially she's changing up the concentration of the sodium thiosulfate. Okay, as you guys can see, there's 3 containers here, each one of which has a different concentration. So she's now going to put 20 ml of that reactant into the HCl, and we're going to see what happens. Okay.
Now, at the same time, we're gonna start the timer.
Yeah, we're going to start the time. We're just going to see. So as you guys can see right here, 0.05 is the weakest out of all of them. What signs are we looking for, Xantha?
We're looking to see if it gets cloudy or not. Because they're 2 colorless transparent liquids, and they're going to precipitate out sulfur. The sulfur is going to appear like a cloud.
Oh no, guys, does that mean what I think it does? Is it going to stink?
Yes, you're
Oh,
going
boy.
to. Yeah, but you're wearing a mask, so you'll be fine, sir. And I'm going to record the time it takes for that to happen.
Well, you know, I don't know about that, Xantha. I'm wearing a mask, but, you know, somebody who passes gas, you still smell it through a mask.
Okay, well, you know, like, seriously, sir?
Oh,
Okay, can you see it or no?
yes, it's pretty beautiful.
Okay, so this is what it looks like. Can they see
Yeah,
it?
they can, yeah, it's very nice.
So that's at around 43.46 seconds.
Okay, perfect.
So
Great.
there
Xantha.
you go.
That's
Okay?
43 seconds.
All right, so that's the first one. That's system 1. We're going to do system 2 now.
System 2, as you guys can see, is 0.025 molar more concentrated in comparison to the first one. So that's what Xantha is going to do. She's going to fill that up. Okay? No worries, Xantha. I know this is just like novel for everybody.
The cooking channel has nothing on it.
Oh, absolutely. Guys, we should start our own network, you know?
Except they can eat their stuff and we can't.
Well, I could try to eat this later, but I
Should we
don't
tell
think.
them what the grade 10s are doing on Thursday?
Well, maybe we'll organize something for them later.
Yeah. Do you want to know what the grade 10s are doing on Thursday?
I don't think they want to know.
They don't know. You're asking them. I don't know. Do they want to know or not? What did you do in grade 10 that you liked doing, guys? You remember?
No, they're not going to unmute because I'm recording.
Oh, okay. Can't they text?
They can, yeah, they can chat for sure.
Okay. I'll tell you what they're doing. They're making ice cream.
Oh boy.
Would you like to make ice cream again?
Oh, Deli Coley. Anthony said ice cream. He knew it.
Yeah. Would they
Madeline
like-
Madeline too. Oh, Chelsea, yes, please.
So you'd like us to make ice cream with you? If I give you the recipe, can you buy the ingredients?
Creme de la glace. Is that even a question? Says Johannes.
I guess not. Okay, so we're gonna send you the recipe on how to do it at home. You just have to get, most of it you already have at home. There's just one thing you don't have probably, which is cream maybe.
I'll organize a day, guys, where we'll do it together. Maybe in the last week of school.
Yep.
Okay, so I think that's the plan.
Okay, and if you're in physics, we'll do it at the same time because whenever there's a chemistry class, there's a physics class.
Okay, good.
So we can hit you all up at the same time. Would you
Good.
like to have a big Zoom session?
Oh yeah, that would be amazing.
Okay, we'll experiment with the grade 10s.
Okay, so
Hold on, I gotta reset my stopwatch too. Okay, so here we go.
Okay, so this is a higher concentration. I want your hypotheses, guys. What do you think is going to happen? Do you think it's going to happen faster or slower by Xantha increasing the concentration of sodium thiosulfate? What do you think? What do you guys think before it happens? I know you're listening. I know y'all listening. Anybody? Faster, faster. I'll see a lot of faster. Justin Parker, Ben Cote, and time. Beautiful.
Okay, so 34.43.
34 seconds. Excellent.
So was that faster?
That, I don't know. Is it faster? Less time? I guess so. I guess it means faster. Guys, we can clearly see that it was indeed faster simply because we used less time and therefore made the rate bigger. Okay? Yeah, Rip is right.
Okay.
So we're going to do the last one. Xantha so gracious to have provided this for us. with the last concentration. And that concentration is at 0.0100, I think, moles per liter. Perfect. Okay, so slightly higher concentration. You guys should probably predict what happens. We're going to use the timer again, and then we'll see what happens. 3, 2, 1, and 4. That's wonderful. And let's see. Higher concentration means faster. Let's see if this follows the trend.
There you go.
Okay, and that's it.
21.06.
21.06 seconds. Yes, beautiful. Beautiful, beautiful, beautiful.
Okay, so neat. Okay, so the next one after this, we've done concentration.
Perfect.
So could you bring up the next one? And
Absolutely.
I'm gonna get this out of the way
Yep.
for them?
All right, guys. So we're back with temperatures. Xantha's going to mix these two solutions together: the oxalic acid with the potassium permanganate. Okay, and we're going to start a timer. And now we're going to see what the effect of temperature is.
I know, this is at room temperature. So
Okay.
room, it's at around 22.
Right, the room's around 22. Guys, what, Xantha, what are we looking for?
We're looking for the permanganate to disappear. It's going to be reacting with the acid, and it will be basically the color will disappear.
Oh, excellent. So we're looking for that just to disappear.
That's why it's on a white background.
I see.
Okay?
So we're gonna keep our film on it. We're gonna keep our camera on it, and then the moment it disappears, we can just hit the we can just check the time in which it took.
Yeah. It's going to take a look.
Yeah, no worries. They're patient. They like staring at grape juice.
Oh yeah, well, if they can't drink it, what else can you do with
That's
it?
right. You can just stare at it the whole time,
Right?
right?
Can you drink it? No. Wait, not everything goes in your mouth.
Tristan seems to enjoy drinking grape juice. That's what I'm concluding from all of this.
Yeah. Well, what can I say?
Well, Xantha, this is wonderful
Overjoyed.
because it's still very purple.
Okay. I had a stirring rod right over here.
Oh, busting out that stirring rod. Let's go. So what's happening at the same time, as you guys can see in the background there, the other permanganate is being heated, okay, just to see if temperature has an effect on it. And when you guys, we've talked about already something called the Maxwell-Boltzmann distribution, the graph, and you remember how temperature could affect it, right? It shifts the graph to the right or the left, depending on what you're actually doing to the experiment or the substance in question. Okay, you're either making it hotter or colder, right? So that's just trying to hurry the reaction up by increasing the number of collisions.
So that we have more effective collisions.
That's right.
Because they know collision theory, right?
We've talked about it, yeah.
Okay, here it goes. It's starting.
You guys notice that, well, I don't know how well you guys notice, but the color is starting to change slightly. Okay. Oh, here we go. You notice the color is starting to change. Oh, it's becoming more and more red. And over time, as she does this more and more, it's going to pretty much disappear after a while. Okay. And we're going to see what happens when we increase the temperature. Oh, she's just stirring by hand now, swirling it. Excellent lab technique there, Xantha.
So this is at around 3 minutes and 30 seconds.
Perfect.
Okay,
3 minutes and 30.
Yeah.
We'll let it keep going on its own, and
Now,
we're going to do the other one.
I'm going to show you the other one.
And this is around 3:30, okay? She's pouring it in. We'll see how much time it takes. The beautiful purple color yet again. And she's now going to use a stirring rod to try to increase the number of effective collisions between the two. Okay, now remember, the one on the left is essentially warmer, okay, or has more energy than the one that's on the right.
So basically what I'm gonna do to make this is I'm gonna heat the whole thing up here and I'm gonna see if it takes longer. Or less time, basically.
Yeah. So if it took less time to get to this nice red color that you saw earlier, then we know that increasing temperature does indeed have an effect. And there you have it, folks. We are now at what time, Xantha?
We are at 1 minute.
Yeah, so it's about 4 minutes and 30 seconds. We already have this red color here, so you guys can see the effect that temperature has. It increases the speed significantly, and therefore increases the rate.
So they're about the same color now, so
Yep.
There you go. Boom.
Perfect. Thank you so much, Xantha. Great.
Oh, you overjoyed.
Okay, so we're now going to look for the last one momentarily.
Okay.
So guys, we're back with the recording here. What we're looking for is essentially the solutions to turn dark. Okay, and then which one will turn dark faster. So if you look at catalyst versus no catalyst, whoa. Okay.
Which one got darker faster?
Catalyst in this one, catalyst in this one. The result was pretty much instantaneous. Okay, perfect. So thank you for watching, guys. It's another quarantine edition of the Xantha and Tam show.
Dude.
Yep. Thanks so much for coming, guys. And I will see you on the next recording. Ciao.